Hello everyone, this video is focused on factorization and its techniques, and this is a very important part of the algebra section, and its application is inevitable in most of our working. So we should very carefully look at the factorization techniques. So I'll start with very basic, and then I'll proceed in difficulty level, and I'll try to devise some rules or some hierarchy of working so that whenever we get in a situation where we have to factorize, we know how to sort out and apply the appropriate techniques. So I'll start with the very basic, and starting from here, if you know how to find the HCF of numbers, this is as simple as that. So let's say if you have to find the HCF of numbers 8 and 12, you know how to do it through the column method. So I'll use the column method here. As you can see that the highest common factor here is 4. So 4 times 2 is 8, and then 4 times 3 is 12. So the highest common factor is this number that divides both the numbers, and that's the highest possible number. Let's proceed to another example. Let's say we have 6x and 4x squared. So again, using the same column method, we are going to take out the HCF. So first of all, we take the numbers. Among 6 and 4, we have 2 as the highest common factor, so 2 times 3 and x along, and then 2 times 2, 4, and x squared along with it. Now that we are done with the numbers, we look at the variables. We have x and x squared. Remember, whenever we have any variable common out or any number common out, we always look out for the smaller number or the smaller power. So here we have x power 1, and here we have x power 2. So we'll take the smaller power out, which is x power 1 here. And then dividing by x, we get 3, and then we get 2x from the remaining section. And guys, this happens to be our HCF now. This 2x is the highest common factor. Now I'm going to just make very minor changes, and that will give you an idea of how does the factorization of algebraic expressions look like. Let's say we have 6x minus 4x squared. So that this is an algebraic expression, and then I use the same technique of factorization using the HCF way of working. So this time we have again numbers, we have 2 as a common factor, so we are left with 3x minus 2x squared, and then among the variables we have x as common out, so we are left with 3 minus 2x. Now as you might notice that this 3 minus 2x is the remaining expression. Our HCF is the product of these two numbers. If we write the HCF times the remaining expression, let's see what we get. We get 2x times 3 minus 2x. And so you can see that this is the factorization done. It's always advisable that you always check back by multiplying, so I'll just give it a try and see if we get the same terms as the question. So 2x times 3 gives us 6x, so that's correct. 2x times negative 2x is negative 4x squared, so that is also correct. So guys, this is a very basic technique that you take the HCF of all the terms here. But what's important here, that you must be very careful in deciding the numbers, the variables, and the signs. So for that, it's always advisable that you first deal with the signs, then you deal with the numbers, and then you deal with the variables. So that's something that you can make a note of. Signs, then numbers, then variables, and if you have more than one variables, so you can say that one variable at a time. You deal with one variable at a time. Right, so let's move on to our rule number 1 for factorization. Our rule number 1 for factorization happens to be the same discussion that we have just done, is that whatever number of terms you have, any number of terms, your first thing, any number of terms, the first thing that you have to do is, I'll write in blue the hints, so that is HCF of all terms. Let's take some examples for that. And we have the first example, 16a squared b minus 18ab squared. At this stage, I would still encourage you to try it by yourself first. You may pause the video here, But if you still don't get it, let's take a look at it one another time. So first of all, they both are even. So looking at the hierarchy that I just shared, I'll first check the signs. This is positive, this is negative, so signs are not common. Then I go for the numbers. I see that they both are even, so they must be divisible by 2. So 2 times 8 is 16. I'm doing nothing to the variable, so I'm just carrying along them as it is. And then 2 times 9 is 18 with the AB squared. Right, that being said, our next stage is we're done with the numbers, then we look at the variables. Since we have 2 variables, so we look at one at a time. Now, if I start looking at the powers of a, we have a power 2 here and a power 1 here, and we take the smaller power out, so we have a as common out, and the remaining is 8ab minus 9b squared. And then still we have b common in both the terms, so again the smaller power of b is to be taken out as common, so we have 8a minus 9b, and thus this 8a minus 9b is our remaining expression, and our HCF is the product of all these numbers outside that you see. So guys, HCF is 2ab times the remaining 8a minus 9b, and that's your factorization done. How easy is that? Alright, just to add on here, if you're not very sure what number comes in when you are taking out common, so there's another way of doing that. Let's say we are looking at 16a squared b, and the number that we decided to take out common is 2. So what we do is, we take this term and we divide it by the number or the variable that we are taking out as common. So this time we are taking out 2 as common. So then you do cancellation, 2 1s and 2 8s, and whatever is remaining after the cancellation is the term that comes here. I'll repeat. If you are not sure what's the term after you take out common, you simply do this division, term divided by the common factor, and that will be your answer. Alright, so and another note that you might want to add is that whenever you take the negative sign out or a negative number as a common out, you just simply reverse the sign. Let's say this is our example number 2, and this is AB bracket x minus 1 plus c x minus 1. Now this is sort of a level up for us, but we will keep the same way of working. So I'm going to make this column method. Now remember, you are always taking out a common factor. Now among the common factors, it can be numbers, like we used to take out common 2. So it could be numbers. Then we also took out common as a or b, so it could be variables. But it could be any expression as well. It could be a common expression as well when you're taking common out. So in this case, this x minus 1 is a common expression in both the terms, as you can see from here. This x minus 1 is a common expression. So instead of any number or a variable, this time the whole expression is taken out as common. And when you take out this expression as common out, this x minus 1 is taken out, so you're left with AB from the first term, and similarly this expression goes out and you're left with C as from the second term. And so this happens to be our HCF, and this is our remaining expression. I'm just writing in short remaining expression. And so the factorization of this would be x minus 1 times AB plus C. And you can always multiply it back to check. So x minus 1 times AB, it would give you this term. X minus 1 bracket times this C would give you the second term. Alright, so that's sort of a level up. And let's add more difficulty to this one for our third example. So the third example is A bracket x plus 2, negative x, negative 2. Now this is a sort of a level up, as I just mentioned. I see x plus 2 and here I see negative x, negative 2. How about taking the negative sign common out from the last two terms? If I say negative 1 as taken out common, it's absolutely correct to say. And by just doing that, now you may see that this x plus 2 and this x plus 2 are the two common factors here. This time this whole bracket is a common factor. So I'm going to factorize that and take out the whole common factor out. And so from the first term I'm left with a, and the second term I'm left with negative 1. And hence my factorization is simply x plus 2 times a minus 1, as easy as that. Now I'll keep the same example here in the display and provide you with another example. Let's take our fourth example here, and this is again level up from the previous example. So it's x plus 1 whole squared plus 2 times x plus 1. Let me give you an example first. If you have a squared plus 2a, so you always take the smaller power out and you will be left with, when you factorize that, you will be having a plus 2. Means 1 power and 1 power. And then from here you are taking the a power 1 completely out, so you're left with 2. The same, try to connect this example with the following question. Now there is a very important note that that's actually a mistake that I want to share, and this is very commonly observed. And let's say we have an example, 4x minus 16x squared. Now using the same column method that I shared, you have 4 among the numbers, so that's 1x. We don't show this 1, so we write like this, simply x, and then 16 is now 4x squared. Now the mistake is, if you are now taking the x power 1 common out, most of the students ignore this term and say this is simply negative 4x, which is the wrong way. What you're doing is, you are taking out a common factor. As I mentioned above as well, that when you are taking out the common factor, then you're dividing each of these terms by the common factor. So the term is x, and when you divide by x, you're not left with 0, you're left with 1. So you have to write 1 here. Similarly, when you were dividing 4x squared by this common factor x, that's how you got 4x in the remaining expression. So this is a mistake that normally do whenever you are taking the factor common out and it happens to be the same factor as the whole term, then you should write 1 there, and the factorization would be 4x bracket 1 minus 4x. Right, so our rule number 1 is about done. It is any number of terms and your idea is HCF of all terms. That's our rule number 1. Any number of terms, and what you do is you take out the HCF of all terms. And I've placed it in the rule number 1, the first position, because of a certain reason, which I'll share with you at the end of the video. Now let's move on to rule number 2. So our rule number 2 is, if we have 4 terms. So if you have 4 terms, what to do? And the keyword is, if you just remember this keyword, if you have 4 terms, you pair up, and you remember quite easily. Alright, so what we have here, let's take the first example for rule number 2. So we have x squared plus 9x minus 4x minus 36. Now we have 4 terms. Clearly there is no number or variable that is common in all of them. So our first rule is done with, we cannot apply it anymore. And now we look for the second, is pair up. So let's see if we pair up the first, second, and the third and fourth terms. And so, just like before, factorize each pair. Now that you have paired up, factorize this pair. So I'll do it separately here. If it is x squared plus 9x and you factorize that, you get x as common out, so x plus 9. And so x times x plus 9 is the factorization of the first pair here. I'll replace it by the factorized form, x plus 9. And then for the second pair, let's say we write it here, so negative 4x, negative 36. This time, first of all, the sign, so you see a negative sign common out, and then you also see that 4 is common out. So I'm going to take the negative as well as the 4 common out together, and we will be left with negative 4 times x is negative 4x, negative 4 times positive 9 is 36. So the factorization of this second pair is negative 4 times x plus 9. And I'll replace the second pair by its factorized form. This is where we are. And as you saw at the end of the rule number 1 that we had the examples, instead of a number, we now have the whole bracket that is common out. This bracket x plus 9 is common in both the terms. So this time we take out the x power x plus 9 as common out. If I take this as common out, what am I left with from the first? I'm left with x. Similarly, if I'm taking x plus 9 as common out from the second term, I'm left with negative 4. So you might want to change the bracket, that doesn't matter. X plus 9 and x minus 4 is the factorization, and that's job done. Right? So we have 4 terms, we pair up and factorize each pair. Now the key thing here is that once you factorize each pair, this bracket should be the same. It should have the same terms and the same signs. Only then you'll be able to then take this whole bracket as common out, and this is where we end up factorization. Let's take another example and see what you do for the next example. I'm going to take the same terms. So we have x squared minus 4x plus 9x minus 36. Right, so we have 4 terms. We pair them up, we factorize each pair, so I'm going to do directly here right now. X times x is x squared, x times negative 4 is negative 4x, so that's the factorization of the first term done. And then from the second pair, I have 9 common out, so we are left with x minus 4. This would have been the choice as well. And so now we have the whole bracket x minus 4 common from the both terms, and I'll take x minus 4 common out, and I'm left with x and plus 9 from the 2 terms, and that's factorization done. Now a non-example or something that you should not do is that you do not pair the first and the last. It means the extreme powers. Sometimes it may not work, most of the times it may not work for us. So you don't pair up. I can jumble up this pair. If you look at the examples, the 2 examples are x squared plus 9x minus 4x minus 36. So the terms are same, I just shuffled the positions of 9x and negative 4x, and this was factorized even in both cases. Now, non-example is if you pair up the highest degree term with the lowest degree term. So if I try to say, let's say if I say x squared minus 36, and then we have 9x plus 9x and then minus 4x, and then I try to pair up, this pair is not working for me. X squared minus 36 don't have anything common. Here 9x minus 4x, they are like terms, so that you can simply subtract 9x minus do the subtraction 9x minus 4x, and that will be it. So it won't lead us to an easy working. So the non-example or something that is not to be done is don't pair up this extreme powers. The highest and the lowest power, don't pair them up. Okay, let's level up and we move on to our third example of the second rule. So we have 5ax minus 3ay minus 5bx plus 3by. Alright, so by now we know that it has 4 terms, and when we have 4 terms we pair up, so I'm pairing up the first, second and third, fourth. So from the first pair we have only the factor a common, so I'm taking a, and then this is 5x minus 3y. And similarly, now this is a critical position. If I take positive, because these are not same signs, so if I take positive number out, let's see what happens. So we have b and b common in both the terms. I'll get negative 5x plus 3y. Now look at the 2 brackets. I said earlier that they have to have same term and same sign. But this is positive 5x, this is negative 5x, this is negative 3y, and this is positive 3y. The numbers are same, the values are same, except for they have reverse signs. So guys, this is where we have to decide, and this comes with practice, that we have to take out a positive sign out or a negative sign out. So I'm taking a negative sign out. So if I take negative sign, remember whenever you divide by a negative 1, you multiply by a negative 1, or you take out common a negative value. You take out common for a negative value, it simply reverses the sign. Reverse the sign. So if I take negative b out, this negative term is now positive. This positive term would be now negative. And now you can see that 5x minus 3y and 5x minus 3y, this is the same bracket that we are getting. That was our condition when we make the pairs and factorize each pair. This bracket should be the same. Now finally we have achieved the same brackets, and so we move on to 5x minus 3y. We take out the whole bracket out. So from the first term you're left with a, and then from the second term you're left with negative b. And that's the factorization done. So another example. Let's move on to example number 4 here. So what's example number 4? Example 4 is 6x squared minus 4x plus 9x minus 6. You may want to pause the video here and try to do it by yourself first, and then you can see my video. So this is 4 terms. I'll pair up and then I'll factorize each pair. 6x minus 4x. So among the numbers it's 2 common, and among the variables it's x common. I'm doing it directly here. If you don't feel confident, you can still go back to the rule number 1 at the start of the video and then come back to this example. So 2x is common from here, and I'm left with 3x minus 2. And then from the second pair I have 9x and minus 3, so I'm going to take 3 common out, and then 3 times 3 is 9, so 3x minus 3 times 2 is 6. As you can see, the two brackets are same, and we are good to go for taking out the whole bracket common out. 3x minus 2 is taken out as common. So from the first term we are left with 2x, and then from the second we are left with 3. And that's factorization done. So now we move on to our rule number 3, and so a summary of the rules that we have done is any number of terms, and you do HCF of all terms. And then rule number 2 that we just did, if we have 4 terms, we pair up. Now we're moving on to the third rule, and you might guess we are descending in the number of terms. Any number of terms in 4 terms, and then now we're going to discuss 3 terms. Let's see what 3 terms has to say. Okay, so if we have 3 terms, that's rule number 3. Rule number 3. If we have 3 terms, key term to remember is mid-term breaking. The idea is you will have 3 terms. You'll break this middle term into 2 terms, right? And so you will have 4 terms. And 4 terms you already have just discussed how to factorize 4 terms for an algebraic expression. Right, so I'll start with an example, and then I'll provide you with more insight of how to do it. So our first example for rule number 3 is x squared plus 12 minus 7x. So guys, the first thing that you have to make sure is that it is in descending powers of x. By descending I mean decreasing. So after highest power 2, you should have the next power 1, and then you have the next power 0. Remember, a constant means, if it is 12 written, it means it has a variable but with power 0. So 12 means 12 times x to the power 0. So first thing is I rearrange them. So once I rearrange them, x squared stays at the first term. This 7x is now shifted at this place, and this 12 comes at the last place. So now you can see that the powers of x are in descending order, 2, 1, and then 12x. 12 means 12x power 0. Right, so we have this set of three terms. What we're going to do is identify two very important numbers. These are the product and sum. Now, the product is the product of these numbers, the coefficients of extreme degree terms. Extreme degree means highest and lowest. So what's the number here? 1, and the lowest degree term is 12. So we have the product 12, this is the product, and S stands for the sum. Okay, so the sum is simply this middle term. The coefficient of this middle term is the sum here. Now, once we have identified the product and sum, product is obtained by multiplying the extreme degree terms. Don't forget the signs with them. And then sum is the middle terms coefficient. And there we are with 12 and negative 7. Now we have to find two numbers which fit into this criteria, that their product is this product and their sum is the same values used when added give us negative 7. So we can think of some pairs for 12. I know 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and then 6. So 6 times 2, which is the same pair, so I don't go further than this. These are the three possible pairs. Now which one of them can help me get a 7? So you can say that this is the only pair that gives me the number 7 by adding is 3 and 4. So I'll write 3 and 4. But hey, the problem is we are getting the sum negative 7. And our product is a positive number, so 3 and 4 won't make it into this condition. Now what if I just simply give the same sign negative to both of this? The product will still be a positive sign, but if you add them, negative 3 and negative 4 will add up to negative 7. And that solves my problem here. So I've got two numbers whose product is positive 12 and whose sum is negative 7. Now I'm going to replace this middle term by these two new terms that I found. So x squared as it is, and this 12 as it is, and I'm going to break this negative 7x into these two terms. We have negative 3 and negative 4, so this is negative 3x and this is negative 4x. So the idea that if we have three terms, you do the midterm breaking is done according to this criteria. Once that is done, you have 4 terms, and now you can see how easy is that to factorize. So we have 4 terms. So the first pair is this one and the second pair is this one. X is common from the first pair, and then negative 4 is common from the second pair, and there you are. Now you have the whole bracket common from the two terms, so you take that out, x minus 3, and then you left with x from the first and negative 4 from the second, and that's your factorization done. Let's take another example of the same midterm breaking rule, and I'll provide you with more insight on identifying these numbers and what are the key hints that help us to find the numbers. For example number 2 on this, let's say we have x squared plus 1x minus 12. Okay, so how do we identify? The first thing is we have 3 terms and our job is to factorize. So for 3 terms we have to do the midterm breaking. It's already rearranged in descending order, so not to worry about the order. Then I have to identify 2 numbers, the product p and the sum s. The product p is the product of the highest and lowest degree term, which is 1 times negative 12. And so the product is negative 12, and the sum is the middle degree term, which is simply 1. I'm just taking the coefficients here. Now what do we do here? Product is negative 12. Now whenever the product is negative, this is the important or key point here. The product is negative, it means you are multiplying different signs. So I know from the sign of the product that the values that I'm looking for should have different signs. And if I had product a positive value, then I knew that I would have been looking for same signs. Alright, now once this is sorted out, I also know that if I am dealing with different signs, I'll be doing subtraction. Like -2 plus 3 leads to subtraction. And if I'm dealing with same signs of some numbers, I'll be adding them. So these are some hints that you want to look at it. See here, product is -12. If product is -12, I am dealing with different signs. And then sum is +1. So when you add or subtract, you always have sign of bigger value. When you have add or subtract, you take the sign of the bigger value. So I'm sure that by now you might have guessed out the two values here. The sum of these two values is a -12, and sorry, the product of these two values is -12, and the sum is +1. Another hint, this is also part of the notes. Another hint is whenever your sum is +1, if sum is +1 or -1, you are looking for consecutive values or consecutive numbers. Only their difference is positive or -1. So let's find out the numbers. -12, irrespective of the sign, 12 is 1 times 12 or 2 times 6 or 3 times 4. As you see, the sum is +1. So 1 it means I'm looking for consecutive numbers. So 3 and 4 is my choice. So I'll place 3 and 4. Now this product is negative, so I know that one of them has to be positive and the other has to be negative, and that is decided with the help of sign of the sum. Sum is positive, it means the bigger value gets the positive sign and the smaller will have the negative sign. So there we are. We have the two numbers identified, which are +4 and -3. So I'm going to break down this middle term. This x squared and this -12 are written as it is, and then breaking down this +1x into +4x and -3x gives us 4 terms. And again, 4 terms is something that we already have done quite well. So factorizing after pairing. So first pair gives us x times x plus 4, and the next pair gives us -3 times x plus 4. You see that I took out the negative sign common out, so I reversed the signs of each term inside. And then this is the whole bracket out, this is 4. So this time the whole bracket is common, so I'll take that out. And from the first term I'm left with x, and from the second I'm left with -3. And that is job done. I hope these few notes would definitely help you. Let's move on to our next example. Okay, so let's move on to our third example for the rule number 3, which is midterm breaking. And the third example is 2x squared minus 6x minus 8. Now I'm going to do it by two ways. They're not different ways, but two routes to the same situation, same solution. First of all, I'm going to simply find the product and sum. The product is the product of the highest and lowest degree term. So in this case, the product is 2 times -8, which is -16, and the sum is -6. Upon investigation, we see that product is negative, so the two values will be of different signs. So one is positive and the other is negative. Sign of the bigger value, which should have the sign of the sum, so bigger value comes with a negative sign here, and 8 and 2 are the numbers that I'm looking for. And you can check that 2 times -8 is -16, and then 2 plus -8 is -6. So guys, the pairs are done. So we have 2x squared plus 2x minus 8x minus 8, and now we have 4 terms, so we pair them up and factorize each pair. So this is 2x common from the first pair, you're left with x plus 1. Similarly, -8 is common from the next pair, this is x plus 1 again. And now the whole bracket x plus 1 is common. We take that out and we're left with 2x minus 8. Now mostly students make a mistake here. Remember, whenever you are asked to factorize, you are asked to completely factorize. It's very important for us to notice, completely factorize. It means you cannot take any further common out. As you can see here in my bracket, I still see that these two are even numbers, and even numbers means they must be divisible by 2. So this is not complete factorization, because I still see that these two are even numbers, and if it is even numbers, they must be divisible by 2. That means I can divide or take out 2 common out from this second bracket. And so what I have here is 2 times x plus 1 times x minus 4. So again, it's not a wrong way, but it does create a loophole or set a trap for you that you may forget to further factorize that. Sometimes it really happens. So in order to avoid that, I place the HCF of all terms at rule number 1. That's the reason why HCF of all terms is our rule number 1. You see that these are even numbers. So the first thing I would do is take out this 2 as common out, and then what I'm left with? X squared minus 3x minus 4. And now I factorize the pair, the expression inside this bracket. And for this pair, we have the product P equals to 1 times negative 4, so that's negative 4. And then sum is negative 3. And the two numbers that I see for this one are these x squared. How do you get a product 4 is by in the table of 4, so that's negative 4x plus x minus 4. You can check it by properly doing that. And then 2 times the first pair has x common in them, so x minus 4 in the bracket and x outside. And there's another way, there's another important thing that you note. If nothing else is common, x minus 4, they have nothing common, but just to show, you will always show that 1 is common from them. This is another key area to remember. If nothing is common, you can always show that positive 1 or negative 1 is common out. So here we are, we have the second bracket, and these two brackets same, so now we are taking the brackets out, x minus 4, and then from the first term we are left with x, and the second is plus 1. And now it guarantees that I have no other factorization to be done. Normally students do get mistake here, they do not fully factorize that, or they do not completely factorize that. Alright, let's move on to our next example, and that would be the last example for our rule number 3. So our fourth example for rule number 3 is negative x squared plus 9x minus 18. Now in this one again, it's not a necessity, but I would prefer if I have this first or highest degree term positive. So I can take out negative 1 common out, and when I take negative 1 common out, it reverses the signs. Either you do this, if you do the other way around, that's no issues, but norm is that you tend to have the highest degree term with a positive sign. So I'm preferring that. And now we have 3 terms here, and the product is 1 times 18, which is 18, and the sum is negative 9. I think that you have guessed the two pairs of numbers whose product is a positive number. If it's a positive number, I know that both values have the same sign. So the pair that I find is negative 6 and negative 3, and you can check the values. So here we are, negative is outside the bracket, x squared as it is, and then this 9x is broken down to the new two terms, which are negative 3x and negative 6x, and this 18 as it is carried along. And then we have 4 pairs which result in this factorization, x minus 3 and x minus 6. So you might want to remove this bracket, which is unnecessary. It's simply negative x minus 3 and x minus 6. And that's factorization done using midterm breaking. Right, so now we move on to our fourth rule. And the fourth rule is, this leads to a very important observation. So first of all, let's take that observation into consideration. Let's say we multiply x minus y with x plus y. So if you know how to expand the brackets, this is how you do it. You take the first term of first bracket and you multiply it with all the terms of the next bracket. So this is x squared plus xy, and then for the second term, which is negative y, you're multiplying it with the other two terms of the next bracket here. So you get negative xy and negative y squared. As you can see that positive xy and negative xy are the same terms with different signs. So they cancel out and your result is x squared minus y squared. So the result here is x squared minus y squared, and this was when we multiplied x plus y times x minus y. So guys, this result is an important result for our rule number 4, and what I'm going to do is try to describe that in words. So x squared minus y squared is basically difference, because this is being subtracted, difference of two squares. And why is it squares again? Because I can write this first term as a complete square, the second term as a complete square. If I'm successful in doing that, then I can write as the product of their sum and their difference. I'll repeat, difference of two squares can be written as the product of their sum and difference. Right, so keep that in mind, and let's move on to our next example. That's the first example for our rule number 4. So the first example is x squared minus 4. That's quite an easy example to understand. So our job is, I'll write that here, I'll write the identity here, x squared minus y squared is equal to x plus y and x minus y. Okay, so our job is to make the negative sign in the middle and the other two terms as complete square. Now x squared can be written as the square of x, that's quite easy to show. And now 4, can we express 4 as the square of some number? Yes, we can. We can express 4 as the square of 2. So our framework is fulfilled. We have written this given expression as a difference of two squares. If that's the situation, then we can write it as a product of their sum. The sum would be x plus 2 and the difference would be x minus 2. And guys, this is the factorization done. That's rule number 4, and we call it the difference of two squares. In fact, that's the key word that we are going to remember for our rule number 4, just like other two rules. So this is what we have to remember. Difference of two squares is our key term for rule number 4. Okay, so let's take another example for this rule. We have 4x squared plus 9. As I mentioned, that I'll be increasing in the level of difficulty. So now 4x squared, the framework that we have to fulfill is this negative sign in the middle, and the term before and after the negative sign have to be a complete square. So 4x squared can be written as 2x, and you can check by multiplying back, and 9 is the square of 3. Once the structure is made, that the difference of two squares, then I'll write it as this product of their sum and difference. Okay, that was quite easy to understand. Let's take another example. Let's do the third example. So that is 36 minus 49x squared. Again, our job is to write 36 and this 49x squared as a whole square of something. And clearly 36 can be written as 6 squared, and 49x squared can be written as 7x squared. You remember, square means, any number squared means that number is multiplied by itself. So when I'm checking for 49, I'm checking for a number that when multiplied by itself gives us 49. In that case, 7 is the number. So once you've written as the difference of two squares, you write that as the product of their sum and difference. And as you can see that we are expressing this expression as a product of factors, hence our factorization is done, and no more factorization can be done in any of these brackets. So I'm going to take just a few more examples for our rule number 4. So our fourth example for this rule is 3k squared minus 75. Now there's a slight trouble. 3 is not the perfect square of any number, so I cannot make it a whole square of something, and neither is 75. Can I write 75 as a square of some number? It's a very difficult task, and I don't want to involve the square root signs. There is a trick with that, but it's not going to help us much. What we're going to do is, remember our rules of factorization. The first rule of factorization was HCF. No wonder I placed it at the first place, because you always do this first. You always check if there is any number or any letter or variable is common in all of the terms or not. In short, do we have HCF of all the terms? If yes, then that's your first thing to do. So I'm going to first take out 3 as common out, because 3 can divide both of these numbers. So 3 times k squared minus 3 times what is 25? 3 times what is 75? This would be 25 here. So now we have this situation, k squared minus 25. And at this stage, you can easily identify that k squared is the square of k. So that's written like this. 25 is the square of 5. So there we are. Once the structure is obtained, you can write it as the product of their sum and difference, k plus 5 and k minus 5, and that's factorization done. Alright, so I have a few more examples solved. If you want to challenge yourself, pause the video and then you can turn back to the solutions that I've done. Let's move on to this one. 64n squared minus n power 4. As I mentioned that I'll be increasing in level, so here we are. 64n squared minus n power 4. As you can see, again, HCF of all terms. Can I take n squared as common out already? If yes, then that's going to help me a lot in the later part of the working. So that's 64 minus n squared. And now you can write 64 as square of 8, n square as square of n, so there we are. This is n square as it is, then 8 minus n and 8 plus n, and that's factorization done. Next one is a slightly different and difficult example. Let's see how you do it. Again, you can pause my video to challenge yourself with this question, and then you can see my video after you have done that. Alright, so what's going on this time? Again, the structure of this question is helping me, and our fourth rule was 2 terms. If we have 2 terms, we know that we have to do the difference of 2 squares. This has 2 terms also, and it has a negative sign also, but it's slightly difficult to understand that first term is this whole bracket squared. If this is whole bracket squared, then haven't I already fulfilled this condition? That's the first term squared, and then I can write 4 as square root 2. So this will be x plus 1 whole squared minus 2 whole squared, and you can see that the structure is still in place. This is first term squared minus second term squared. If that's the case, then I can always write it as x plus 1, which is the first term, plus the second term, and then x plus 1 minus 2. So this is a sum and difference and the whole, and then we have taken the product of these two sum and differences, right? So then we can simplify. We can always simplify x plus 3 and x minus 1. So guys, this is the factorization of the given expression. For the next question, this is a slightly more difficult. As I mentioned, I will be increasing in amount of difficulty. So here we are. Let's say for our next example, that's the 7th example for this rule, we have 16x squared minus 2x plus 3 whole squared. You might want to pause the video and do it by yourself, try it by yourself first. So please go have a go at it. We can write 16x squared as the square of 4x. So that's quite easily done. This is the whole bracket squared, so that is also serving the purpose of getting this structure, a squared minus b squared. The difference of 2 squares, it's getting me the same structure. And if that's the case, I can write it as the product of their sum. Now this is tricky. Product of their sum, so 4x plus 2x minus 3. And then, let me correct this bracket. This is 2x minus 3, and then this is the sum taken, so this is 4x minus 2x minus 3. Now this is what I always advise to my students. When you see a negative out, when you see a negative sign out, you always don't forget to take your shield. Your shield is your brackets. So whenever you have a negative sign out, don't be hasty, don't be very quick about it. Just use the brackets and you'll be definitely much safe to work with. Alright, so when you have this, we have 4x plus 2x minus 3, and here you have 4x minus 2x. See, this is where the common mistake is. We forget to multiply this negative sign with the negative 3. We only do that correctly because we are using the brackets. Now that the bracket is in place, I know that this negative and 1 is multiplied by each of the terms. So negative 2x and positive 3. And now we simplify them. So this is 6x minus 3, and from the second bracket we have 2x plus 3. So guys, this is about the first 4 rules for factorization. And now we move on to the fifth one. Okay, so now we move on to our fifth one. This is a summary of the rules that we have done so far. If it is any number of terms, you take the HCF of all terms. If you have 4 terms, you pair up and factorize each pair. If it is 3 terms, you take the midterm breaking. If it is 4 terms, you do the difference of 2 squares, which is a square minus b square format, and then you write it as product of their sum and difference. And now the fifth rule. So our rule number 5 is, now rule number 5 for factorization is first of all based on, just like rule number 4, it is based on an identity. So I'm going to share this result first. A plus b times a plus b. So let's see what happens. A times a is a squared. A times b is ab. B times a is ba or ab, irrespective of the order. And then b times b is b squared. So guys, we have a squared plus 2ab plus b squared. Now you might notice something about this result, and I'm going to share here with you. The first thing is, if we have a plus b whole squared, I can write this a plus b times a plus b, which is a plus b whole squared, and this is equal to a squared plus 2ab plus b squared. First of all, we have 1 and 2 square terms. We have 2 square terms, and then the middle one is a product term. We have this as a product term. Right, so before I go for generalization further, let's see if I have this different signs. Let's see if I have a minus b times a minus b. In short, if I have a minus b whole squared, so you multiply it like before, you get a squared minus ab, and then you have negative ab and plus b squared, so negative ab plus b squared. So this negative ab and this negative ab combines, we get a squared negative 2ab plus b squared. So in short, if I could write these two results together, if it is a difference, if it is a negative sign here, then the negative sign is transmitted to the middle term, which we call as a product term. The square terms are still the positive, you may notice from here. Square terms are positive, so they are always positive. Make sure you have these two square terms positive. The product term could be negative or positive. Alright, also there is a definite 2 here, so you will always write as a multiple of 2. Multiple of 2. These are the 3 observations about the product term and 2 observations about the square terms. They are square, they are always positive. This product term, this can be positive or negative, and it is always written as a multiple of 2, and a and b is the product of these 2 numbers here. So just keep that in mind, and we'll do our first example based on that. I'm writing this result here, a squared plus minus 2ab plus b squared. Just to show you guys that if there's a negative in here, you will get the negative in the product term, otherwise the square terms remain the same. So our first example for that is factorize x squared plus 10x plus 25. Now I know this is 3 terms, and you can do the midterm breaking. It's very easy to do midterm breaking here. The product is 25 and the sum is 10, so it's clearly x squared plus 5x. 5 and 5 is a pair for the numbers, and you can do x plus 5 times x plus 5. That's clearly done. But sometimes it's good to practice this one, so that's why I listed as another rule, and I'll be very brief in explaining this. So we have x squared plus 10x plus 25. Now according to this statement, this observation, we have two square terms. So can I manage two square terms here? Yes, I can. I can write x squared as the square of x and 25 as the square of 5. Now about this 10, it has to be a multiple of 2 I just mentioned. So 10x has to be written as 2 times something. In fact, 2 times 2 other values. One of them is x, which is already identified from the first term, and the other one is 5 from the second term. So you can see that it results in 10x, and there we are. So what we do here is, we write this middle term, this product term, as a multiple of 2, and 2 is there, 2 has to be there, and these two remaining numbers are actually the numbers coming from expressing these squares. So now we have the structure in place, x square of the first term plus 2 times square first term, second term, and then square of the second term. So this is x plus 5 whole squared, and which is the same as saying x plus 5 times x plus 5. Let's give it another example, and then we'll see. So our example number 2 for this rule is x squared minus 10x plus 25. And we are going to use this result, a squared plus 2ab plus b squared is equal to a plus b whole squared. Similarly, if the product term is a negative, then you'll have a negative in the middle. Right, so I can write x squared as square of x. I can write 25 as square of 5. And then I can write this negative 10x, the sign as it is. 2 has to be there. You've already found x and 5, so you can simply write them like this, and then you're done with that. And then finally, you can write it like x minus 5 whole squared, which can be further written as x minus 5 times x minus 5. So you've shown this expression as a product of its factors, and no more factorization is possible. Hence, this is complete factorization. Right, so by now you have 5 rules of factorization, and I guess first 4 rules are more important. The 5th one is actually a result that comes from this formula. This is the result that we used. It's sometimes at high level it's very important to notice. At MIT level or the IGCSE level, it's okay if you want to do it with the midterm breaking, or you can use the result directly. Now I have, at the end of the video, I have some challenge questions for you. I hope you want to try them, and you can always pause the video when I start the question and then try it yourself, and then after you have done or attempted, you can see my solution. So here are the challenge questions. Okay, so the first challenge question is factorize x squared minus a squared plus 2a minus 1. The challenge is that whatever the rules that you have done, only those rules are used, but they have to be used in a very different way. Keep in mind the first rule till the 5th rule for solving this question, that the challenge is to factorize this expression. Let's see how you do it. So what I'm going to do is, I'm going to take x squared as it is, and then all of this, I see these 3 terms quite suitable for making them into a complete square, which I'll explain now. So I take negative sign out, I have a squared, positive is now reversed sign, and negative reversed to positive. So now you can see that I can express these 3 terms as a complete square, or in other words, you can do the midterm breaking, and after the midterm breaking, what you can do is, the product is 1 and the sum is negative 2. Clearly 1 is obtained by multiplying 1 by itself, and then 1 plus 1 is 2. But sum is negative, it means it's not 1 and 1, it's in fact negative 1 and negative 1. So I'm going to use a square minus a plus 1. This still results in negative 2a. And our next step is x squared minus a minus 1 for the first pair factorization, and then negative 1 times a minus 1. So what do we have here? X squared minus a minus 1, and then remaining is a minus 1 again, which can be written as x squared minus a minus 1 whole square. Still the factorization is not yet done. So what I'm going to do is, you see the other result, a square minus b square, that's difference of two squares. So first square and the second square and the negative sign in the middle. So I'm going to use that result here. So that means we can write this as the product of their sum. So x plus a minus 1 and then x minus a minus 1. And you might be observing that I'm using the bracket sign very carefully. And now once I've done that, I'll simply write them in the simplest form. So it's x plus a minus 1 times x minus a plus 1, because this negative is multiplied with both of the terms here. So guys, this was the challenge question, and no new rules were used. I have just one more challenge question for you, and that will be the end of our today's video. Okay, so our next question, the next challenge question is x squared minus 4x minus 5 bracket x squared minus 4x minus 12. It's quite a huge question. Minus 144. Now this is definitely a challenging question, but if I try to look at it carefully, 144 is the square of 12. So if I could make this question in this structure, a square minus b square, the difference of two squares, that means if I could make this first term as a square of some number, I could use that result on a bigger scale. But the problem is, these brackets are not the same. This is negative 5 and this is negative 12. So I can't write this as a whole square of something. Now this is quite a big question, and remember, whenever we have such big questions, we can always trim them or make them look smarter by doing substitution. So what I'm going to do is, I'm going to substitute. I'm going to say that let x squared minus 4x, because this is something common in both the brackets. So I'm going to use this substitution, x squared minus 4x, and now when I use y, this is y minus 5 and then y minus 12 and minus 144. Right, so this is definitely quite an easier version of the same question by this substitution. And now we expand that, and you use the arrows, you know how to expand two brackets. So this is y squared minus 12y and then minus 5y plus 60 minus 144, and then you collect the like terms, y squared minus 17y minus 84. Now at this stage you notice that this is a 3 terms expression, and you remember from our rules, if it is 3 terms, we have the midterm breaking going on. But since we are dealing with slightly bigger numbers, so you can grab your calculator if you can't do it mentally and try to do the midterm breaking of that. Here the product is the product of extreme degree terms, which is negative 84, and the sum is negative 17. As the tips and tricks I told you for product and sum, product is negative, so you are taking the two different signs for multiplication, and sum is negative 7. It means a bigger value will have the negative sign. So I have worked it out already, and this is y squared 17y and minus 84, and the pair that is found to be fitting this situation is of negative 21 and 4, and you can check them by multiplying and adding. Okay, so we break down this negative 17 into two new numbers, which are negative 21 and 4. So y squared minus 21y plus 4y minus 84. And now we have 4 terms, so we know how to do it. If it is 4 terms, we factorize. We first pair up and then factorize each pair. So from the first pair, we have y common out, so it's y minus 21. And from the second pair we have 4 common out, so this is 4 times y minus 21. And now that the two brackets are common out, y minus 21 is the common bracket, and you're left with y plus 4. So guys, this is factorization done so far, but it's not the complete answer. Some of you might think that the factorization is done complete. Now there is an important note that the examiner or the question maker never gave us the variable y. We introduced it by itself. So whenever you have such substitutions done, you always must get rid of the variables that you introduced by yourself. So I will substitute back and I'll replace y by this substitution that we made at the start. So now we have x squared minus 4x minus 21. Similarly, x squared minus 4x plus 4. And many of us might be thinking that's the answer. But this is why it was a challenging question. I think we still have 3 terms in each of these brackets. And if there are 3 terms, I can always look for middle term breaking. So guys, this is why it's a challenging question. Let's try to look into the midterm breaking of each of these brackets. So I'll bring it up there. And now x squared minus 4x minus 21. If you look at this bracket, the product is 1 times negative 21, so negative 21, and the sum is negative 4. And you can identify the two numbers that are going to replace this middle term. I have done it already, so it's x squared minus 7x plus 3x minus 21, and which when factorized gives us x minus 7 and x plus 3. Similarly, for the other bracket, again the product is the product of the highest degree terms, so 1 times 4 is 4, and the sum is negative 4. Sum is negative 4, and the pair that happens to fit in this situation is x squared minus 2x plus 4. You might want to give it a check, but this is the correct one. So now 4 terms and you pair up, so this is x minus 2 and x minus 2. So finally our answer for the given question is x plus 3, x minus 2, x minus 2, and x minus 7 for the given question. So guys, this is factorization done. It was definitely a challenging question. You use substitution, then when you thought that you gotten rid of any variable that you introduced by yourself, and you did factorization, there was still more factorization coming up, so you had to factorize it further. It was definitely a challenging question. So I hope you liked this video, you learned from it, and I hope factorization is not going to be a problem anymore for you. If you like this video, please hit the like button. If you have any concerns, please provide me with your feedback in the comment section. You can also tell me for any videos on other topics that you want me to do, and I'll definitely come back to that. And please share with your friends. Don't forget to subscribe my channel and hit the bell icon. So guys, if you want this whole discussion onto a printed form, I have this whole discussion here on the board here, so that you can consult it at any point of time instead of going through the video again and again.